5.1a, the unit circle. So we're going to do 5.1 in two stretches. A unit circle is defined as a circle with the center at the origin. So the center should be at 0, 0, and the radius of 1 unit. Okay? And so we've looked at this before, sort of. We didn't define the radius as 1 unit, but we've certainly looked at the definitions of sines, cosines, and tangents in terms of rotations on a coordinate grid. Well, in the unit circle, we're fixing the radius to be 1. Hopefully you remember from a while back that if you are on a coordinate grid and you wanted to know what the sine of theta is, you should look at the y value and divide it by the radius. Well, if we're saying that the radius is 1, then y divided by 1 would be just the y value. So on the unit circle, the y value is the sine of an angle. And if you look at the cosine, and the cosine is x over r, then, excuse me, hopefully you'll see that the cosine of the angle is going to be the x-coordinate if you're on the unit circle. And the tangent's still going to be y over x. So the cosecant would be r over y. Okay, and again, you could make this a 1 on the unit circle, and then here it would be r over x, and the cotangent would just be x over y. And so that is what this looks like if it was a unit circle. This is the equation of a unit circle, or the formula if you would like. We'll see that a little bit more in pre-calc. So how does that help? Well, if I tell you that you have a point on the unit circle, and you should be able to find all 6 of the values. Now the reason I only have these 4 listed here is because we just said that the x would be the cosine of the angle. So that's the cosine, and that is the sine of the angle. If I look at this particular value over here, then I can still think of the sine as a half in this case, but that is still consistent with it being opposite over hypotenuse. Now the reason I say that is because if I look at the opposite, if the opposite is 1 and the hypotenuse is 2, well then that should ring a bell because that looks like sort of a special triangle, right? So if I try to eyeball this, I would say that the opposite side, the distance from here to here, is about half of the radius. And so we have this value here is 1, and this value would be 2, but if we're on the unit circle, then the distance from here to here is supposed to be 1, right? So we're going to write that 2 as 2 over 2, which is 1. So then this side would be a half. Well, then that makes this side the square root of 3 over 2. Because now let's go back for a second. If I, well, let's just do it this way. So if I go back to the definition, 1, 2, this would be the square root of 3, right? So that is a 30-degree triangle. And then on the unit circle, we know that this side is 1, so 2 divided by 2 is 1. So I need to then divide all the sides by 2, and then that would be exactly the picture that goes with the square root of 3 over 2 and a half. Based on that, then, you should be able to find the values of the tangent, the cosecant, the secant, and the cotangent. Well, the tangent from just above here would be y over x. So the tangent of theta would be a half divided by the square root of 3 over 2, which is the same as multiplying by the reciprocal. So I get the tangent of theta is going to be 1 over the square root of 3. And then that really gives me all the information that I need. So now we'll finish this off and we'll try to write these nice and neat. So we know that the sine of the angle was a half. That means that the cosecant of the angle would be 2 over 1, which is 2. We know that the cosine of the angle was the square root of 3 over 2. So that means that the secant of the angle is 2 over the square root of 3. And the tangent of the angle is over here. So for the cotangent, I can just flip that and I get the square root of 3. Okay. It even works when you don't have a special triangle. So here actually I created a special triangle. You don't have to have a special triangle for this to work. So a negative 2 over 5 would be the x value, right? So if from here to here is 1, then a negative 2 over 5 would be just over there. So we can tick mark it there. I'm just going to go straight up from there. And then this is the triangle that we have. Okay, we already know that the cosine of the angle, we are on the unit circle, so the cosine is a negative 2 over 5. So we can flip that for the secant, right? So that means the secant of the angle is a negative 5 over 2. We know that the sine of the angle would be the square root of 21 over 5. So that means that the cosecant of the angle is 5 divided by the square root of 21. So I need to do a little bit of work. I need to find out what the tangent of the angle is. Well, the tangent of the angle would be y over x. So the y value is square root of 21 over 5. And dividing by a fraction is multiplying by the reciprocal. So I'm just going to multiply right away. Those cancel. So that means that the tangent of the angle is the square root of 21 divided by a negative 2. And I can flip that then for the cotangent as a negative 2 over the square root of 21. Okay, I did want to show you something else, and that would be that you can still label these, even though you're on the unit circle, you can still label these with sort of the values that you have over here, if you think of this in terms of triangles. So the cosine is adjacent over hypotenuse, right? So if you had said that's a negative 2, and that's 5, and then the hypotenuse is 5, then the sine would be, let's see, the sine would be opposite over hypotenuse, so clearly the 5 should be the same, but then this is the square root of 21. Okay, do you still get the same tangent and cotangent if you had marked the triangle this way? Well, that's the right triangle, right? So the tangent, based on drawing the triangle, or based on using these measurements as actual triangle measurements, would be what? The tangent of the angle would be opposite, square root of 21, divided by adjacent, and you see you get exactly the same value as I had over here. So just because you're on the unit circle doesn't mean you cannot think in terms of triangles. You can still do that. All right, last part here used to, or not the last part, next part used to provide the information to find values for the missing sine, cosine, and tangent. So if the sine is given, I need to find the cosine and tangent, and I want to find the angle in both radians and degrees. So the sine of theta is a half, and it's in quadrant 2. So I'm going to draw a picture for that. So we've done this sort of before. If the sine is a half, then opposite is 1, right? The opposite side is 1. And that means that the hypotenuse is 2. So it's a 30-degree triangle that looks a little like this. And that means that this side over here is the square root of 3 with a negative. So let's see, what do we know then? Then the cosine of the angle would be a negative square root of 3 over 2. And the tangent of the angle would be, 1 over a negative square root of 3. So I'm going to put the negative over here. And then I still need to find theta. So theta would be, actually theta is the rotation from here to here. That's the theta that I need. But it's related to this one. And that one over there, we know is 30 degrees, right? That's a 30-degree angle right there. Well, if it's 180 to here, then theta would be 180 minus 30 would be 150 degrees in terms of radians, in terms of degrees, and then you have to convert that. And this is where it comes in handy if you sort of know that 30 degrees, how many 30s go into 180? Well, 6. So 30 degrees is a pi over 6. And how many do you have? You have 5 30s in 150, so this is 5 pi over 6. All right. Let's do that for the tangent of theta. So the tangent of theta is a negative square root of 3, and we're in quadrant 4. So we'll draw something in quadrant 4. And the tangent is opposite over adjacent, so think of the adjacent as 1. So if that's 1, then this is the negative square root of 3. So we draw a triangle based on that, and then you can hopefully see already that this must be a 60-degree angle over here. So that means that this is 2. So what about the sine of the angle? Well, the sine would be, so we're over here, always the reference to the x, so it's a negative square root of 3 over 2. The cosine of the angle would be 1 over 2. And then the angle in terms of degrees and radians. So if this is 60, and that's 360, then that would be 300 degrees. And then in terms of radians, 60 goes in 3 times into 180. So this is a pi over 3 of some sort. Well, 360 degrees is 2 pi. And 2 pi would actually be, could be written as 6 pi divided by 3, right? That 6 divided by 3 is 2. We are 1 pi over 3 short. So 6 minus 1 is, then this must be 5 pi over 3. Okay. Well, then the last part, and you have a much larger unit circle than I have. You should fill in this unit circle on your own, okay? And what that means is that you need to fill in all the missing parts. So for example, that's 0 degrees, which would be 0 radians. So the first one's degree, the second one's radians. We know that, well, I guess I lied a little bit because it's flip-flopped here. That's 180, and hopefully you still know that that is pi. You can see that that's 90 degrees, and maybe you still remember that's pi over 2. So you've got to mark all these. Since it's a unit circle, you know that the radius is 1. So the coordinates here are 1, 0. The coordinates here are 0, 1. And then you can continue with that. And then you have to fill in all these points over here as well. Now, all these are special triangles. So I know for a fact that this line over here creates a triangle and that this gives you a 30-degree angle. So this is 30 degrees, okay? You should know what 30 degrees is in terms of radians, but if you don't, how many 30s go into 180? 6, so that's a pi over 6. And then you need to come up with the coordinates over here. Well, if it's a 30-degree triangle, and let's just do the triangle out here for just a second. So if it's a 30-degree triangle, then the values over here should work even if I don't make the radius here 1. So a 30-degree triangle would be 1 square root of 3 over 2. So what do we know? The x-coordinate is the cosine of a 30-degree triangle. So the cosine is the square root of 3 over 2. So this number here needs to be square root of 3 over 2. The y-coordinate is the sine of this angle. So that is 1 over 2. So this is a half. Okay. The next one in this is 45. So you would create a 45-degree triangle to find those values. So a 45-degree triangle looks a little bit like this. We know that that means that's 1, that's 1, that's the square root of 2. So then the sine would be 1 over the square root of 2. So that goes over here. The cosine is actually the same. It's also 1 over the square root of 2. And then I'll let you figure out how many degrees, or how many radians are in 45 degrees. Okay. Now, it doesn't mean you have to do this for every single one of these, because, look, if you know that this is 30 degrees, then that's 30 degrees, right? Well, then that means that the x, and I need a little more space there, so I'm going to erase this for just a second. I can't right now. Let me do it on the other one. So, let me erase this for a second. All right. So I know that I have another 30 degrees over here. Well, that means I get the same x value, except now the x value is negative. So it's a negative square root of 3 over 2. And the y value is still positive, so that is a half. So the negative square root of 3 over 2 half are the coordinates right here. Now if that's 30, then this is 150. Okay. If you continue this sort of pattern, that triangle is also over here. So the same coordinates sort of apply, except now is not only is the x negative, so we get the same x value, the y value became negative as well. So once you find this triangle, you can sort of use those values here, here, and then they also occur one more time over here. And the same thing happens with the one over here at 45. And then this one is actually 60 degrees, it's 2 30s. And then hopefully you sort of start to see the pattern. Thank you.